Welcome to the session on cloud computing and its application. In this session, we will be talking about Module 3, Chapter number 7, and today's topic is Workflow Application with Task Dependencies. Workflow Application with Task Dependencies. Workflow application are characterized by a collection of tasks that do exhibit dependencies among them. Such dependencies, which are mostly data dependencies, that is, the output of one task is a prerequisite of another task, determine the way in which the applications are scheduled and also where they are scheduled. Concerned in this case are related to provide a feasible sequencing of tasks and how to optimize the placement of tasks so that the movement of data is minimized. What is a workflow? The term workflow has a long tradition among the business community where the term is used to describe a composition of services that all together accomplish a business process. As defined by the workflow management, a workflow is the automation of a business process in whole or part during which documents, informations, or tasks are passed from one participant to another for action according to a set of procedural rules. The concept of workflow as a structured execution of tasks which have dependencies on each other has demonstrated to be useful to express many scientific experiments and gave birth to the idea of scientific workflow. Many scientific applications are composed as a combination of problem-solving components which connected in particular order define the specific nature of the experiment. When such experiment exhibit a natural parallelism and need to execute a large amount of operations or deal with huge quantity of data, it makes sense to execute them on a distributed infrastructure. In the case of scientific workflows, the process is identified by an application to run. The elements that are passed among participants are mostly task and data, and the participants are mostly computing or storage nodes. The set of procedural rules are defined by a workflow definition scheme which guides the scheduling of the application. A scientific workflow generally involves data management, analysis, simulation, and middleware supporting the execution of workflow. A scientific workflow is generally expressed by a directed acyclic graph defining the dependencies among tasks or operations. The node on the directed acyclic graph represents the task to be executed in a workflow application, while the arc connecting the nodes identify the dependencies among tasks and the data path that connect the tasks. The most common dependency that is realized through a directed acyclic graph is data dependency, which means that the output of a file of a task constitutes the input of another task. This dependency is represented as an arc originating from the node identifying the first task and terminating in the node identifying the second task. The directed acyclic graph describes a sample montage workflow shown in the slide. Montage is a toolkit for assembling images into mosaic. It has been specially designed to support astronomers in composing the images taken from different telescopes or points of view into coherent images. The toolkit provides several applications for manipulating images and composing them together. Some of the applications perform background reprojection, perspective transformation, and brightness and color correction. The workflow depicted in figure describes the general process for composing a mosaic. The label put on the right describes the different tasks that have been to be performed in order to compose a mosaic. In the case presented in the diagram, a mosaic is composed out of 7 images. The entire process can take advantage of a distributed infrastructure for its execution, since there are several operations that can be performed in parallel. For each of the image files, the following process has to be performed. That is, image file transfer, reprojection, calculation of the difference, and common plane placement. Therefore, each of the images can be processed in parallel for these tasks. Here is where a distributed infrastructure helps in executing workflows. There might be another reason for executing workflow on a distributed infrastructure. That is, it might be convenient to move the computation on a specific node because of a data locality issues. For example, if an operation needs to access specific resources which are only available on a specific node, that operation cannot be performed elsewhere, while the rest of the operation might not have the same requirements. A scientific experiment might involve the use of several problem-solving components that might require the use of specific instrumentations. In this case, all the tasks having these constraints need to be executed where the instrument is available, thus creating a distributed execution of a process which is not parallel in principle. Next, we will see workflow technologies. Business-oriented computing workflows are defined as an composite of services, and there exist specific languages and standards for definition of workflows such as business process execution language (BPEL). In the case of scientific computing, there is no common ground for defining workflow, but several solutions and workflow languages coexist. Despite such differences, it is possible to identify an abstract reference model for a workflow management system. Design tools allow users to visually compose a workflow applications. This specification is normally stored in the form of an XML document based on a specific workflow language and constitutes the input of the workflow engine, which controls the execution of the workflow by leveraging a distributed infrastructure. In most of the cases, workflow engine is a client-side component that might interact directly with the resources or with one or several middleware for executing the workflow. Some frameworks can natively support the execution of workflow application by providing a scheduler capable of directly processing the workflow specification. Some of the most relevant technologies for designing and executing workflow-based applications are Kelper, Eggman, Cloudbus, Workflow Management System, Offspring. This is a diagram showing the abstract model of workflow system. Next we'll see the Kelper. Kelper is an open source scientific workflow engine built from the collaboration of several research projects. The system is based on the which provides a solid platform for developing data flow oriented workflows. Kelper provides a design environment based on the concept of actors, which are reusable and independent blocks of computation such as web services, database calls, etc. The connection between actor is made with ports. An actor consumes data from the input port and writes the data results to the output ports. Kelper is in its ability to separate the workflow of data among components from the coordination logic that is used to execute workflow. Thus, for the same workflow, it supports different models such as synchronous and asynchronous model. A workflow specification is expressed using a proprietary XML language. Eggman, Directed Acyclic Graph Manager, is a part of Condor project and constitutes an extension to Condor scheduler to handle job interdependencies. Condor finds machines for the execution of the programs but do not support the scheduling of jobs in a specific sequence. Therefore, Eggman acts as a meta scheduler for Condor by submitting the jobs to the scheduler in the appropriate order. The input of the Eggman is simple text file that contains the information about the jobs, pointers to their job submission files, and dependencies among jobs. Next is Cloudbus. Cloudbus Workflow Management System is a middleware platform built for managing large application workflow on distributed computing platforms such as grid and clouds. It comprises of software tools that help end user to compose, schedule, execute, and monitor workflow application through a web-based portal. The portal provides the capability of uploading workflows or defining new ones with a graphical editor. In order to execute workflow, Cloudbus relies on GridBus broker, that is GridBus resource broker supporting the execution of application with quality of service attributes over a heterogeneous distributed computing infrastructure including Linux based clusters, Globus and Amazon EC2. Cloudbus workflow management system uses a proprietary XML language for specification of workflows. Offspring supports the integration with an distributed computing middleware that can manage simple bag of task applications. It provides a native integration with Aneka and also supports a stimulated distribution engine for testing strategies during development, as it allows the definition of workflow in the form of plugins. It does not use any XML specification. So in this session, we have seen a workflow application with task dependencies. The content was taken from the textbook Mastering Cloud Computing written by Rajkumar Bhuya. In the next session, we will talk about Aneka task-based programming. Thank you.